Hey, everybody, actually, does anybody want to come do it real quick for me? Yeah, thank you. Yeah, you will. Hurry, run. You can choose, but if you, okay. Are you sure you don't want to just do all while you're up here? Okay, sorry. Hey, explain to us how you decided to do what? Everybody listen.
So there's three of them, right?
Three what? Three of what?
Three of those.
Or three times that, you mean? Yeah, okay.
And then there's that X, right? And then there's that, and there's three of those.
So why'd you put three on top?
Because, like the flower thing, the roots go on bottom.
There you go. Perfect. Power on top. Hey, there was a lot of you that had the middle one right, so I want you to try to see if you can, will you come up and explain it? Because I've explained it once before. So you have it right. Somebody that has it right, come on up. Yes, come on up, Will, thank you. Okay, so there's a lot of you with the middle one wrong. So this is the one you all need to pay attention to because there's going to be one like this, very similar on a quiz or test. Okay. Listen.
So because the exponent is only touching the 3, we have that, and then with also the 3. And since all of it is under the square root, it would all be to the 1.
Does that make sense? Okay, awesome. Thank you. You explained it beautiful. Awesome. So notice they're assigned their individual powers. The one on top just makes it, these powers won't change, right? And then putting the 2 on bottom ensures that it's the square root. So then, yeah, perfect way to go. Okay, so this one we all got right for the most part. We have 3 and x both raised to the 3 halves. Okay, awesome. Let's go on. So today we're going to be doing 4-2. We're just going to be doing more practice with what we learned last time because there's a lot. And we'll just do some even more advanced problems today, but the same idea. So we're just going to be working all of this worksheet today, doing examples. I'm going to give you tons of time to practice today because we've learned most of it. It's just now let's practice it even more. So we learned that rational exponents are radicals and radicals are rational exponents. Roots are on bottom, powers on top. Just like Dylan said. So now we're going to go through and simplify these. So simplifying something like this, if you didn't have a calculator or if I said show your work, you would say, okay, the only way I really can simplify this is know that this is a root, so this is the cube root of 125 to the first power, right? So then you would break it down, pull out groups of 3. So that would be 5 times 5 times 5, that's 125, so we'll have a 5 as our answer. Just positive 5 cube roots have 1 root. And today we're just simplifying, so we don't have to write plus and minuses for this. Isn't this the square root of 64, everybody? Which we know is 8, correct?
Yeah.
Okay. We don't need to put plus and minus because anytime if I just say to you, what's the square root of 64? It's just 8. If I say find, it's different in the instructions. If I said find all the real roots, does that make sense? You would need plus and minus. Okay, so looking at this one, guys, it is 2 problems in 1 because you got to recognize same base. So we're using properties of exponents. So we add, correct? So that would be when you multiply, you add your exponents. So that's 1/4, right? And so now we would say, okay, is that the most simplified form? Now, I wasn't very clear with you the last time. If you start with rational exponents, your final answer will be in rational exponents. Because I had a few of you say, how do you know when to stop here or stop at the radical form? Does that make sense? So didn't we start with rational exponents? We're ending with rational exponents as long as it's in the most simplified form, and it is. So we're done. Does that make sense? However, if I then in the instruction said, what's that in radical form, we could keep going. Yes. Oh, yeah. 1/2 plus 1/2. We're not multiplying, right? When you multiply, you add. So we should just have 1. Good fix. 7 to the first, which is 7. Good fix. I'm glad you said that. Nobody else got that? You just didn't say anything? So 7. When you multiply, you should be adding. 1/2 plus 1/2 is 1. Did everybody fix that?
Yeah.
Okay. All right, looking at this one. When you multiply the same base, you add your exponents, right? So 1/3 plus 1/3. Now there's like 3 ways we could look at this. 1/3 plus 1/3 plus 1/3. What is that? 1, right? 3/3. You're right. So 3/3 is 1. So it's -5. is our answer, which makes sense because isn't this cube root, cube root, cube root? So let's think about it both ways. So we're going to have the cube root of all of those, which there's 3 of them. Does everybody see it? Okay. Okay, so do 1 through 30. Like today, I'm just letting you practice, ask questions, check your answers, ready, set, go. So if we can do these really easily, let's not spend a lot of time on it because this is the easy stuff. So if I said to you rewrite this in the simplest form, we just simplify by the best means possible. So with this one, isn't it base 81 raised to the 1/4 raised to the 4th? Raise the power to a power and you multiply. So won't that just be 81 to the 1st? Okay, so 81. With this one, how would I simplify? Properties of exponents, guys. It's like back in secondary math 1. Wouldn't it just be when we multiply you, add? So that would be 2 add y to the 3/2. Now, did we start with exponential form? So our final answer is done. Everybody good? Okay, looking at this one, isn't it properties of exponents, you guys? So even though there's parentheses here, there's no addition sign, right? So we can reorder it. That's just 3 times 4 times x to the 1/2 times x to the 2/3. So we'd keep going, 12, and then when you multiply, you add, right? Is everybody good with this?
Yeah.
Okay, so we would get x to the 7/6, and then once again, we started with rational exponents, so we'll end with rational exponents. Everybody good? I don't want us to spend time on this if we're good. So you would know how to do this one. When you divide them, you subtract the top from the bottom. You guys aren't giving me very much confidence that you learned how to do properties of exponents a few years ago. You too are such little gossip teens. Okay, so this is simplified to be 3/1, right? And 1/3 minus 1/2. Did you know that? That's how you do that? You promise? And then if you got a negative exponent, you'd flip it over a fraction. We're good with this stuff? Okay, let's get to the harder stuff then. Let's ignore that. Okay, looking at these, see if you remember how to do them from yesterday. Let's give it a try before I just start teaching, because we learned it yesterday. So you'll go to page 2. And we're starting now on 1 on page 2, 1 and 3. Try it. If you get them right, we'll just let you keep going.
Yeah. How I would match. 54.
So let's look at number 1. How many of you simplified it by putting them under the same radical, because we can multiply together and then simplify? How many of you did it? I know Rebecca just said she did it a little bit easier way. Isn't the square root of 4 2? Times the square root of 25 is 5, which is 10. That was a quicker way. Both ways are correct. That's beautiful either way. Okay, number 3. Go for it. Okay, so tell me what you did. Okay, you took the cube root of 20. Okay, so Chip did it the easy way, which is great because that's really the smartest way. The cube root of 27 is 3, correct? So that's just 3 times the square root of 3, which is 3 square roots of 3. I went through and did it the hard way. Any of you do what I did and say, I see that 27 is just 3 to the 3rd power? Anybody think through it like that or anything? Yeah, I mean, same idea, but anyways, okay. All right, go for, okay, so this was our answer. We all got that? All right, awesome. Do 7 and 11. Use absolute values when needed. So isn't that even root, odd exponent? Even root, odd exponent, right? Did you guys simplify number 7 yet? Is this what you got? Okay, so even root, odd exponent. So think about it. Don't I need absolute values? Because we're not going to ever have a negative underneath an even root when we're dealing with all real numbers, right? So needs absolute values because this is an odd exponent. Even root, odd exponent, you need absolute values. Okay, so this one, what do we get? Okay, let's do it then. Did you get x, y to the fifth, square roots of z? Even roots, odd exponent, odd exponent. We need absolute values. Everybody good? Do I need to explain? If it comes out an odd exponent, then we need absolute values, except for constants, because that's finding the actual root. Does that make sense? The square root of, okay. Awesome. Okay, so do 7 through 15. And I know it says, now notice in the instructions on your actual worksheet, it says assume all variables are positive. If you see that on the homework, you don't need to put absolute values ever, but I'm having you cross that out so we can practice putting absolute values for this one. So cross that out. Okay, let's go on to the next section, okay, because now we have to actually do something, then simplify. So in this one, we're multiplying. We know we can multiply. So on the outside, we have 4 times 3. I'm going to reorder it. 4 times 3 times the square root of 2x, watch. And then now we have an 8x. Why do I not multiply them together? Because then I'm going to be re-splitting them apart, right, everybody? So I'm just showing you the work behind it. We have the square root of, I'm going to reorder this. That's 2 times 8 times x, right? So we have 4 times 3 on the outside, and then underneath we have 2 times 8 breaks down into 2, 2, and 2, correct? Yeah. X and x. So now we're pulling out groups of 2. So we pulled out everything. We pulled out a 4. We already had a 4 on the outside. We had a 3 on the outside. We now pull out a 2, another 2, and an x. Multiply it together. 12 times, yep. 12 times 4, 48, and x. Now let's do the absolute values if necessary. Even root, odd exponent. So we need absolute values. If I cross out the all variables are positive. Because we were just looking at your test today, me and Mr. Robertson. I think it's going to have you simplify and then put absolute values. Does that make sense? So let's practice doing both in one problem. You'd get a lot of, that's like part of half right, half wrong. Okay, so with this one, we would reorder it so we can put them under the same root. So we have the cube root of -9 times 12 times, now look, we have x squared and x, isn't that x cubed? Yeah. And then we have y to the 4th and y, so I'm going to write y to the 5th. So now we can simplify it. 9 is 3 and 3, 12 is 3, 2, and 2. So we'll pull out we're pulling out groups of 3 for this one, right? Yeah. So don't those have to stay? Okay, so we pull out a 3. Now, how many groups of 3 do we have in x cubed?
3.
No, how many groups of 3? 1 group of 3. So we have an x on the outside, right?
Yeah.
And then how many groups of 3 do we have in 5 y's? 1. So we have y to the 1st on the outside. And then how many would be remaining underneath? 2. Does everybody understand why? So we write, now make sure you tuck in that cube root. Left was 2 times 2, which is 4. And then we had a y to the 2nd power, because there was 2 remaining. Do we need absolute values? Even root? Nope, so negatives are fine, no absolute values needed.
What is this odd exponent? Is that like with?
Yes. Oh, yeah, we ignored the negative on accident. Shouldn't it be negative? Yeah. Sarah, thanks for catching that. Okay, 316 through 24. So there's a couple different ways we could divide and simplify these, right? Like yesterday, we were just right away we were rationalizing the denominator. However, there are times when it would be smart to not do that first. Here's an example of why. Look on 25. We have the square root of 75 divided by the square root of 3. We could rationalize the denominator and then simplify, but that's going to be a lot harder if we do that right now. Here's why. Can't 75 and 3 actually simplify? So if they can simplify, you should put it under one radical and simplify it like that first. So since they're both square roots, we can put it under the same square root. So this is really the square root of 75 over 3. So does everybody see why I put them together? Yeah. Because what is 75 divided by 3? 25. So now we just do the square root of 25, which is 5. That was a lot easier than rationalizing the denominator. So here's why, once again, I'll say it one more time, when I would just right away rationalize versus when I wouldn't. If I look at the top and bottom and say that can simplify, I put it together first, even if it doesn't simplify perfectly. So look at number 26. I look at this and I wouldn't rationalize right away. I would say, can I simplify it first? 63 and 7, yeah, we can, right? Yeah, well, so we would just write it under 1. I want you to think, show you the work over 7y. So now let's simplify under the root. So 63 over 7 does simplify. What does it become? Yep. 9, we have an x still, it's on top, and we have y cubed divided by y, that's y squared on top, and that's all over 1, correct? So anything divided by 1 is just itself, so we really have the square root of 9xy squared. So that was much easier than rationalizing the denominator and then coming out to the same simplification, which you would if you did it correctly. So now let's simplify that. Isn't that 3y square roots of, we pull out a 3 for the 9, y squared, pull out a y, and square roots of x. Yeah, and in the instructions, we would actually put absolute values on that y if the instructions didn't say this. Yeah. Questions? Okay, so 29. Look at 29. Everybody skip to 29. Looking at this one, you could just rationalize the denominator, but like I said, if you have the same radical here, then we would want to put it together and simplify if possible. So isn't that the cube root of 4x squared over x? Yeah. So that's the cube root of 4x, which is the cube root of 4x, right? Yeah. So it's much easier to not sometimes. Okay, all right. Now here's the last one, and I did this one for a reason. So notice this one does simplify, but you're going to run into something interesting here. So anytime they simplify, I put them together and do that first. So 18y squared over 12y, correct? So what does that simplify to be? What is 18 over 12? They both divide by? Okay, so 3 halves, correct? This one's different. So then y squared over y becomes a y on top. Now look at your answer. Is this an appropriate answer? No, because don't we still have a radical in bottom? So we would have to, at this point, say, okay, this one didn't get rid of the bottom, so now we'll re-split it up. But now your rationalization will come out much easier. So on top we have 3y, on bottom we have the cube root of 2. So now we'll rationalize the denominator. So we'll multiply at this point by cube root of 2 times 2, correct?
Yep.
So cube root of 2 times 2. So look on top. You have a 3, a y, a 2, and a 2 underneath the cube root. So nothing will simplify, right? Because we need 3 2's. So that the bottom will become the cube root of 2 cubed. Ding ding. Does that make sense? Yeah. No, that was a good question. So on top we know it doesn't simplify. So we have the cube root of 3 times 2 times 2, 12. And then we have a y. And on bottom, we know that that's the cube root of 2 cubed, like I show here. So we know that's 2. So that would be our final answer. So here's why I didn't rationalize the denominator first. There would have been tons more simplification involved after rationalizing. Okay. Which, if you do it right, you'll still get the right answer. Okay, so do 25 through 33. We'll work on that till lunch, and then maybe. Okay, so in the instructions, notice it says rationalize the denominator. You could either just go ahead and read the instructions and do that, or you could look and say, can I make my life simpler? So I'm still rationalizing the denominator technically in the end, because I'm going to look and say, can I simplify it first? Does that make sense? Because then my life's easier. So this is the square root of xy on top. On bottom we have 3x. So notice the simplified version of this is the square root of y over 3. So now I would say, okay, yes, now I do need to rationalize the denominator, but there's less simplification involved. Square root of y over the square root of 3. So to rationalize this, we multiply by the square root of 3 over the square root of 3. So that's on top, square root of 3y's. On bottom we have technically the square root of 3 squared. So we just have 3. Simplify first, because it'll make your life easier. So 42. Look at 42. Do you see how this one doesn't simplify at all? So then we just have to rationalize it. Let's rationalize it smart. So let's split it up. We have the cube root of 3a on top, and on bottom, we have the cube root of, remember yesterday, we rewrote 4 as 2 times 2, correct? B squared is b and b, and then c. So we want all of the bottom to have 3 of them, so that it's that thing cubed, so that it'll cancel out. So we're going to multiply, rationalize by the smallest thing possible. We have 2 2's, we need it to be 2 cubed, correct? So we need one more 2. We have b squared, we need it to be b cubed. So how many more b's? 1. C, we need it to be c cubed, so there's c squared, right? So we've got to do it to the top and bottom, so that it's really just a fancy 1. Now look underneath the root, you got to be careful. Can anything simplify? Pulling out groups of 3, no. So now we can put it together. On top, we have cube root of 3 times 2 is 6. A, then a b, then a c squared. And on bottom, we have this cubed. So 2bc. Can't simplify something under a root with something that's not, so we're done. All right, so practice some of those. If they simplify first, we do that. If not, just start rationalizing by the smallest amount possible. So remember, with adding, you have to have like radicals. So these are easy to begin with. So we're on to page 3. Flip to page 3. Here we go. So we have 9 squared root of 3 plus 2 squared root of 3. To be able to add or subtract, you have to have like radicals. Both the radical part and what's underneath have to be the same. So, yep, these are like radicals. 9 squared root of 3 plus 2 squared root of 3 is 11 squared root of 3. 5 squared root of 2 plus 2 squared root of 3. Can I do it? Nope. Different things, right? So we say that's our answer. Just put a check mark. Simplify. So on to 10. Now we're simplifying. So it's perform the correct operation. This one's addition, so we have to have like radicals. Well, right now it doesn't look like they're like. Let's see if they are. If not, we'll have it in the most simplified form. Factors of 32. I like 8 and 4. A breaks down into 4 and 2. I'm going to stop there because I'm pulling out groups of 2. So I'm recognizing there's 2 4s right there. We'll pull out a 4. We're technically doing the square root of 16, which is 4. So 3 times 4 is 12 square roots of 2. That was just this piece. Now let's simplify this piece. 5, 10. 10 breaks down into 5 and 2. Once again, we pull out a 5. There was already a 2, so that's positive 2 times 5, which is 10. So plus 10 square roots of 2. And what do you know? They are like radicals. 22 square roots of 2. Okay. So do those ones. 1 through 18. Okay, let's just look at something like this now, because you're getting how to add and subtract radicals. This will test your knowledge of that anyways. So we see something like this, because there's a subtraction sign, we're going to be double distributing, because we got to multiply all of this stuff to all of this stuff. So 1 times 2 is 2, 1 times negative square root of 5 is negative 1 square root of 5. I get that we could just write negative square root of 5, same thing. Negative square root of 5 times 2 is negative 2 square roots of 5. Here's where people usually mess it up. Negative square root of 5 times negative square root of 5. First of all, that's a positive, and then that's 25 under the root, right? Plus the square root of 25, right? You start skipping that step of just writing it out, and you start messing up. You do things like just write 25. You get what I'm saying?
Wait, it's not just 5.
No, it's the square root of 25, right? When we multiply square root of 5 times square root of 5, it's not 25, it's the square root of 25, right? So the square root of 25 is 5, right? So that's what we'll then write it as. So really we're looking at this. So combine like terms. 2 plus 5 is 7. And then these are like terms, so minus 3 square roots of 5. Make sure on the online homework, what somebody was running into was that if they type, let's say that this would have been negative 7, they're typing a minus sign, so it was marking them wrong. You got to put in negative. This is a minus sign, right? But if this was negative 7, you'd have to put a negative, not a minus sign on that like so. Everybody understand what I'm saying? And if you're like, I know that's right, then you probably typed in a negative sign instead of a minus sign for that. Like a negative sign instead of a minus sign right there. I'd do that. Do 27, so you just rewrite it because there's a subtraction sign, so it'd be breaking the forbidden rule to square that, square that. So we have 3 squared roots of 2 minus 2 squared roots of 3. This one can kind of confuse people, just there's so much 2s and 3s going on. So 3 squared roots of 2 minus 2 squared roots of 3. Let's go through this one. This one's a good one. Okay, careful here. 3 squares of 2 times 3 squares of 2. There's a lot of room for error in here. What would you get? 9 square roots of 4, which is, we'll keep going in a minute. Let's just keep going like this. 3 square roots of 2 times negative 2 square roots of 3. We can multiply because they're both square roots, so that's negative 6 square roots of 6, right?
Yeah.
Okay, then we also get another negative 6 square roots of 6. And then negative 2 square roots of 3 times negative 2 square roots of 3 is positive 4. Careful, a lot of people want to accidentally say square roots of 3, but it's not. It's square roots of 9. So then you look at this and say, how can I simplify it? This is really 9 times 2. And then let's combine those. So minus 12 square roots of 6. And that's really plus 4 times 3. So we really have 18 plus 12, right?
Wait.
The square root of 4 is 2. 9 times the square root of 4 is the same thing as 9 times 2.
Yeah.
So this would be our final answer. Okay. Yeah, sorry. This was 18 and this was positive 12. So now we can combine those. We did. Look, 30 minus 12 squared is 6.
You know what I'm saying? Like, why wouldn't you?
Oh, you can't combine a radical with a whole number. They're not like, right?
Oh, right. Yeah.
Yeah. Okay, so try some of those. So let's do 33, go for it. Practice a few, then we'll move on. Because if you can do like a few of them, then you know how to do all of them. Okay, so you did the conjugate ones, and are you getting whole numbers for all of them? Right? They're all coming out with no radicals anymore. Okay, so conjugates will make those radicals go away. If they're square roots, that is, because that would be 2 of them and whatnot. Okay, so that's going to help you with number 34. Let's skip to page 4 so that our last 15 minutes we can focus on this. This is different than what you've seen before. So if I said to you, rationalize the denominator. Notice if we just had the square root of 5, we know exactly what to do, right? But now I have this subtraction sign. There's no way to just magically multiply by, like, there's no way to just do this how we've done it before. So the only way, if you have two terms, do you see how there's 2 terms? If you have 2 terms, the only way to get rid of that subtraction sign is to multiply by its conjugate. Why? Because conjugates make it come out to be a whole number. Okay? So with this rationalizing, you'll have to know there's 2 terms, not just one, so we've got to multiply by the conjugate. Conjugate is change of sign in between. So we'll multiply this to the top and bottom. So now we would have to distribute that through on top. So let's quickly do that. It's kind of quite the process here. Square root of 5 times 3, 3 square roots of 5. Sorry, 3 times positive square root of 2 is positive 3 square roots of 2. Square root of 10 times square root of 5 is negative square roots of 50, right? And then square root of 10 times negative square roots of 10 times positive square roots of 2 is negative square root of 20. Now you got to simplify. So we have 3 square roots of 5 plus 3 square roots of 2. We know we can't combine those. But this becomes minus 5 square roots of 2. Right? And this becomes 2 and 10, 5 and 2. So we'll pull out a 2. Left is a 5. So minus 2 square roots of 5. So this is all just the top here. Combine like terms. 3 square roots of 5 minus 2 square roots of 5 is 1 square roots of 5, right? Those 2 I'm combining. Then I'm combining these 2. So we have minus 2 square roots of 2. That was all just the top. Now on the bottom, since they're conjugates, you could say in your head, we could multiply out the whole thing, or we could say in our head, I know the middle term will cancel out, right? For conjugates only, this works. So we only have to multiply the front and the back, because the middle term is going to cancel out. Square root of 5 times the square root of 5 is square root of 25, which is 5, and then minus the square root of 4, which will be minus 2. So that will be 3 on bottom. So there's our final answer. So quite the process. It's testing if you can know how to rationalize. Now do you know how to multiply correctly? And so that's a really great problem for a test. You know what you know. Okay, so how, I'm not going to go through the whole thing, but tell me what would I do to rationalize this? The only reason I need the conjugate is because there's two terms. So square root of 7 minus the square root of 2. We do that to top and bottom. Good. Hey, what about this one? Do I need to do conjugate? No, there's only one term. So we would multiply by the cube root of what? X squared, right? To make it 3 x's on bottom. Okay, then you'd have to double distribute that through. If you guys do those two, go ahead and do 37 through 34 through 44 to practice these last few, and you should be good for the online homework. So this is on page 4. Uh-huh. Up here? Yeah, so that will be 2 cube roots of x squared. That one didn't simplify, right? But that one becomes...
Couldn't you just cancel out these?
No, oh, here's why. Oh, good question. No, because there's an addition sign. Remember, that'd be breaking like what we just learned with simplifying. Does that make sense? Good question. You can do that.